The objective for this experiment is to synthesize 4 coordinate nickel to phosphine compounds and characterize the compounds using ultraviolet visible spectroscopy and multinuclear NMR spectroscopy.
Nickel has a range of oxidation state of 0 to +4, and the oxidation state of +2 is the most commonly found. Nickel 2 was used in a variety of homogeneous catalytic reactions, including the carbon-carbon bond forming Suzuki Miyaura cross-coupling reaction. Nickel compound as a synthetic tool in the fundamental research and a variety of chemical industry due to the importance of the Suzuki Miyaura reaction. Martinez conducted research for the preparation of nickel complex compound. Reaction of nickel complex compound with Ginnard reagent was conducted in this experiment. Extension of Martinez experiment in preparing nickel complex compound was desirable to be investigated. Precatalytic design has been developed for nickel complex compound. Similar species to this variant are often proposed as intermediate of Suzuki Miyaura reaction. Auto effects are demonstrated by isolated compound where the presence of substituent in the 2 and or 6 position of the arrow ring act as protection form against further reactivity of the nickel center, hence increasing the thermodynamic stability of the product.
The procedure has 2 parts, which is the first part is the preparation of the dibromo bis triphenyl phosphine nickel 2. Nickel bromide and phosphine was heating with ethanol alcohol or isopropyl alcohol to prepare the dibromo bis triphenyl phosphine nickel 2. The compound was converted into 2A by reaction with standardized Grignard reagent methylene magnesium bromide and ammonium bromide. Characterization of the product from each step was done by ultraviolet visible spectroscopy in dichloride methane solution and multinuclear NMR spectroscopy. 1 mole % of the compounds was added into 4-bromoacetophenone and phenylboronic acid by heating with tripotassium phosphate and 2-methyl-butan 2-ol to form 4-acetyl biphenyl, and then the product was assessed by multinuclear NMR spectroscopy. Next, second part is the preparation of mole base. Nickel bromide hydrate and DPPE was heating with ethanol alcohol or isopropyl alcohol to prepare the mole base or by reflux with the methanol or toluene. Mole base was converted into 2B by reaction with standardized Grignard reagent, methylene magnesium bromide and ammonium bromide. Characterization of the product from each step was done by ultraviolet visible spectroscopy in dichloride methane solution and multinuclear NMR spectroscopy. 1 mole % of the compound was added into 4-bromoacetophenone and phenylboronic acid by heating with tripotassium phosphate and 2-methyl-butan 2-ol to form 4-acetyl biphenyl, and then the product was assessed by multinuclear NMR spectroscopy.
UAV's results show that 1A has tetrahedral geometry shape and the other compound exhibits square planar. Square planar compound undergo NMR for further characterization due to the magnetism properties. The PPE ligand compound has high yield due to the stability of bidentate phosphine. 2A can undergo further reaction with chelating DPPE to produce 2B. 2A and 2B were used as the precatalysts in Suzuki Miyaura reaction. 1 mole % of 2B gives 85% of acetyl biphenyl. When 2B increased to 2 mole %, the yield of crystallized material is lesser than 85%, but it still gives a high yield. Lack of aspirine can cause the recovery of crude product to be less than 50%. 2A as precatalyst, resulting the turnover number and turnover frequency decrease. Thus, 2A is less effective as the catalyst for the reaction due to the stability of phosphine is less compared to DPPE.